So first thing is they want you to do is they want you to add the functions. And it's not really difficult. It's just you're taking one function, first function here, x squared minus 3x plus 8, and you're adding the other one. But when you have something like this, you're supposed to do what's called combine like terms. Think of it as organizing, okay? And we're gonna look here, like do you see a minus 3x and the operator goes with it, can be combined with plus x? They're both x's.
Mm-hmm.
Why is it that they cannot be combined with the x squared?
Because x squared is like squared.
It's different, yeah, it's not the same. So can you tell me what minus 3x plus x is?
Negative 2x.
Good. Next like terms that I see is plus 8, minus 9. Notice the operator goes with it. 8 minus 9 is?
8 minus 9, 1, negative 1.
Yeah, negative 1. Bring the x squared down. You got x squared minus 2x plus 1, and that's your answer. It's your final answer. You feel good about it, ready to move on to another problem here. The second thing they will almost always have you do, and this is your test question, they rarely have you add them on a test, is you subtract. Oops, why did I put x there? That's all right. So it's f minus g. But what they should really show you is that it's like this, where g is in parentheses. So you start with x squared minus 3x plus 8. That's f. You just bring f down. Minus, in parentheses, x minus 9. You're subtracting the whole thing, not just x. You're subtracting everything.
Here, wait. I found inverse function, functions by reversing operations, where you have the x and the y, or you have y, f of x equals 2x plus 5, and then you substitute f of x for y.
Sure.
So can we do that? Because that's what I'm doing in class today.
Sure. Sure. Let's finish up this example, and really, I mean, we're this is your time. So the sooner we get to what you want to work on, the better. But let's just finish this off here. So you're distributing the negative to both. And so that's x squared minus 3x plus 8 minus x plus 9. Can you simplify this for me? Can you tell me which terms you can combine here?
So negative 4x plus 17.
Good. Okay. Yeah, we can transition here. It sounded like you had one. What was the first one?
Equals 2x plus 5.
Like this?
Yeah.
Okay. This is, have you ever done any cooking or baking in your life?
Yeah.
So there's always, you go to the back of the box, there's a recipe, set of steps. Okay. A lot of steps for a lot of things we do, but the recipe here is pretty basic, but then the actual execution of it can vary. But step one here is, instead of f of x, you write y.
Yeah.
Okay, and you don't have to label the steps, but I'm just telling you what the steps are in case you want to look at them later. Step 2 is to switch or swap, depending on which word you like, swap x and y. So wherever you see a y, you put an x. Wherever you see an x, you put a y. Step 3 is the one that can really vary. You're solving for y. Okay, so to solve for y, you're looking at the side with the variable of y. Just grab a little rectangle here. Why didn't that do? Okay, so on the side with y, 2y plus 5. What do you undo first? Do you undo multiplication by 2 or addition by 5?
Subtract 5 from both sides.
You got it. All right, so seems like you might have seen this before. That's good. You're going to subtract 5 from both sides. I'm going to switch the order, meaning 2y on the left, x minus 5 on the right. What's next to solve for?
And then what you wait.
Look at the side with y. Yeah. What's keeping y from being by itself?
You subtract 2. Wait, or do you divide by 2?
Yeah, so do you see an addition operator here?
No.
Right, there's nothing. When they're squeezed together, it's multiplication. Like if I write 3.4, that's different than 3 plus 4. So if they're squeezed together like this, it is multiplication. You undo by division. And you divide everything by 2, it's not a choice. You have to do both by 2. However, you can usually leave it like this. They're usually okay with that. Step 4, basically done, is you write F inverse instead of Y,
Oh,
like that.
what my teacher does is like she'd leave it as so x equals 2y minus 5 or whatever. Wait, yeah. Wait, no. So yeah, she'd leave it as x equals 2y minus 5, and you subtract 5, and then the answer would be x minus 5, or y equals, or 2y equals x minus 5.
Okay, we had that
Wait,
here.
wait. Oh wait, never mind. You're right.
Should be exactly the same. I mean,
Yeah,
this
yeah,
isn't something that like I would tell you if my way is different than a standard way that shows this. And I rarely do that because it doesn't help you when you're in the classroom.
yeah.
Okay, step 1, right? Write Y. You can't use f of x, you got to write Y. Step 2, you switch x and y. Step 3 is you solve for y. That takes the most work. Once you get it solved for, you replace y with f inverse. Okay. Do you have another problem you would like us to look at?
No. I just
All right, I'm going to make one up here.
uh,
F of x equals 3x minus 1. What is step number 1?
so you do y equals 3x minus 1, and then you substitute switch the y, so it's 3x equals y minus 1, and then you add 1 to both sides, and that's 3x plus 1.
Hang on. I'm hearing the wrong letter. Just when you switch y, x and y, it's 3y minus 1.
Oh, it is.
Yeah,
I thought you take the 3 with the x.
No, what you're doing, let me try and explain this differently, because that's important here. So it's this y comes and takes the place of x. And then the x over here takes the place of y. That's what I mean by you switch x and y. I'm taking your silence like you have no idea what I'm talking about.
Oh wait, sorry. I was just right.
That's okay. Yeah. But you're literally just where instead of writing an x, you write a y. Instead of y, you're writing an x. See, like in the second line here, y is solved for. So when you switch them, it's no longer solved for. You have to you're now solving for y. And that's why you said to add 1 to both sides.
Yeah.
Okay, so we're gonna add 1 to both sides.
And then and that's x plus 1 equals 3y, and then you divide by 3, and then it's f of x equals x plus 1 divided by 3.
So you have to change to this inverse notation. It's different than the original. This minus 1 is different than what we started with. Okay, let me have you try one on your own here. That's okay.
Yeah. X.
All right, so go ahead and try this one on your own and just give me your final answer. Imagine I'm just grading what goes in the box, so just give me your final answer.
So x equals 2y plus 1 x minus 7 divided by 2 equals f minus 1 of x or whatever.
Yeah, x minus 7 divided by 2. Good. All right, so I feel like you've got this part down. So I've got to either increase the difficulty or do some other things. Have you guys talked about composition of functions?
I don't know. I don't think so.
Okay, so let me make these a little more difficult, I guess. You don't have any other example problems that you have from class, so I can get an idea?
I know she did some with like somewhere like square rooted.
Okay,
somewhere in parentheses to the power of 2.
Okay, yeah, that's good. So let's look at some of those. Let's say it's f of x equals x squared minus 3. And you're supposed to restrict the domain. I don't know if you guys are. I'm going to do that though for this problem, in case somebody looks at it online and wonders why I didn't do that. The recipe is the same. Okay, you switch x and y. No difference. But now when we solve for y, we still have to undo this number first. We're going to add 3 to both sides. But how do you undo a square?
You square root it.
Square root it, exactly. Now, when you square root something, there's actually plus or minus. And I don't know how deep you guys are getting into this.
Not that. I don't think we use plus.
But that, yeah, but that does impact your answer here. So this is your inverse. You are supposed to go back to the inverse notation like that. That's what they want to see
Yeah, I
for your
think that's
final
what
answer.
she'd have us right, I think.
Okay, so let's have you try one here.
These aren't really that hard.
Yeah, I like hearing that. I'll make them more difficult kind of as you gain some confidence here with these, but go ahead and try that one, please.
All right. Y equals x2 minus 1. This y2 minus 1. Wait, so x square root that. F of x or f inverse x equals square root x minus 1.
Sorry about that. I was muted for a second. Did you write y equals x squared minus 1?
Yeah.
Did you switch x and y?
Oh, wait. I didn't add is it x plus 1?
Yes.
Oh, I actually subtracted the 1 from both sides instead of adding.
Very important.
Yeah.
All right. So the other type of problem here that you might see is where it gets just a little bit more sophisticated with the something like this, like x plus 3 squared minus 10.
Oh.
Okay. It's just more steps. It's the exact same process. Okay. You start by using y instead of f of x. You still switch x and y. But this time you got to know what to undo first. And this is, I guess, probably much more challenging than the previous ones, but maybe you remember, and it comes from PEMDAS, but you're going the left way because you're solving. So you undo addition and subtraction before multiplication, division, before
So
exponents.
would you add 10 to both sides first?
Yes.
Okay,
so this is x plus 10 equals negative 2 y plus 3 squared. Next,
would you wait? I don't know.
You would undo this multiplication by negative 2. You would divide both sides by negative 2.
Okay. So.
Now this is a small sort of annoyance here, is you tend to not leave a negative on the bottom. So that negative really has to come up to the numerator. Have you seen that before?
Wait, why do you bring the negative up to the numerator?
You want it to look a certain way. There's like a preference. It's like you could wear your shirt inside out, it's still on you, but it's not right. That's what this is. Like, it's not right in the math world.
You think my teacher would mark me off for it?
No idea. That's something for you to think about. If you don't like that, we don't need to look at that too closely right now.
It's easier to just write it like how it is. You know?
Okay, fair enough. Yeah. All right. How do you undo the square?
You square root it.
You square root both sides. Square root on the right, it undoes the square. And you kind of are restarting because you're under the parentheses now. So you restart and you say, okay, what do I do to get y by itself?
Oh, you add 3?
Well, it's currently being added.
Well,
Can't
no, but you like subtracting from both sides of me.
yes, that would do it. Now that you cannot combine anything with the root. So when you say subtract 3,
Would it,
it's kind of like over here off to the left. Or if you want it to be on the right, that's fine too. A lot of students might write it like this, where they have -3, but make sure it's outside the root.
and is that the answer? Other than
That's the answer. Let's just review here real quick. Just like the previous problems, we switch x and y. X became y, y became
Yeah.
x. Order of operations, you undo addition, subtraction, before multiplication, division. Okay. Then you took a square root, and then you have to undo this last thing. So I'm going to give you one to try here. Something for you to think about here. F of x equals 4, x minus 1 squared plus 2. Like you to
squared plus 2.
like you to find the inverse for me, please.
So it would be x equals 4, y minus 1 plus 2. So plus 2 equals 4. And so divide by 4. So 4. Okay, and then so that's x plus 2 divided by 4 equals what minus 1, 2, and then divided by square root. Square root. Did I do this right? I hope I did. Okay, so here x plus 2 divided by 4 equals.
I keep hearing x plus 2. There's a sign error with that.
Oh, wait, what is it? So, oh, is it? Oh, it's minus 2.
Yes.
I keep messing that up. And then that. So x minus 2 is 4, and then equals y. Goes to minus 1. So then, is it y equals square root x minus 2 divided by 4 minus 1? Wait.
Everything you've told me is
wait.
okay.
It's plus 1, right?
Yes.
All right, that's it.
Okay, good, really good. We got time to do another type of problem you'll see. So let's say f of x is 5 square root of x minus 1 plus 6, something like this. Actually, I'm gonna make that -5. All right, the inverse here, same thing. Switch x and y after you rewrite it. So it's x equals -5 square root y minus 1 plus 6. How do you undo addition by 6?
1 minus 1. So would you minus 6?
Yes, yes. So we got to make sure you've got that down. It's x minus 6 minus 5 square root y minus 1. Then you divide both sides by -5. So it's x minus 6 over -5 equals square root y minus 1. How do you undo a square root?
You root it. Oh, wait, no, you square it.
Right. So you undo a square with a square root. You undo a square root with a square. So you're squaring both sides.
So x minus 6 over -5 equals y minus 1. And then it would just be plus, so would it be x minus 6? Oh, and it's square both sides.
Square both sides. And then you add 1. So there's your final answer.
Oh.
Your inverse, x minus 6 over -5 squared plus 1.
All right.
Any questions of that before I give you one to try on your own? Yes, we switch x and y, you undo addition and subtraction first, then multiplication, division, then you square it. Okay, Your algebra is quite good from what I was hearing. So we got to figure out why your grade isn't better, which we can't do today, but I'm sort of surprised here that you're not doing better in your class at this point. So
X equals 2. X plus 3 minus 6. Again, so it's y equals. Is it x plus 6 divided by 2 squared minus 3 equals x? I mean equals y.
yes.
All right.
Don't forget to write F inverse. That's
yeah.
important. It's like getting all the way to the net and forgetting to score the goal. You don't want to do that. All right. Good job today. I think that'll do it for us for now here. I'm gonna go ahead and stop the recording and just close out with you.